Yeah.
All right, simplifying algebraic expressions. We've been talking about like terms the whole year. Can you tell me what a like term is? What do you know about like terms?
If you're adding and subtracting them, they have to have the same value or the
Variable?
variable.
Yep. So there's two things they have to have. One, the same variable. In our case, we're dealing with variables. Really, what it's talking about is base. Okay, it doesn't have to be a letter. It can be anything. It can be a number as a base. All right, but really, what we're looking at as far as this class is concerned is the same letter. Okay, you need to remember that it doesn't have to be a letter. All right, and then number two, same exponent. If it doesn't have the same exponent, it doesn't matter if it's the same letter. Okay? So, the next thing is combine like terms. So how do we combine them? We add or subtract the coefficients. Now, for some reason, students struggle with this. We mix it up with multiplication and division. We mix it up with, or we get confused when there's negatives or something like that. So it really comes down to making sure you understand they have the same letter and the same exponent. Yes. The number in front of the letter. Okay, and in general, that's true. It could be other things as well, but the coefficient is the number in front of your base, whatever your base is. So I'm going to give you a whole bunch of examples here so that we can kind of hit all the different types of problems there are. All right, so example 1 is 4x minus 2x. So there are two terms here. The terms are separated by plus and minus signs, not division or multiplication symbols. Because this is a multiplication symbol right there, we just don't ever see it. We don't ever write it. There's 1, 2. So really, 4x is a term, and negative 2x is a term. We always keep the operation attached to what follows it. Okay? So that's how you tell how many terms you have. Now, the base is the x. They both have x's. And the exponent on the x is a 1. We don't need to write those. It's understood that it's a 1. So they are like terms based on our definition. Same exponent, same base. So how do we combine them? We add or subtract the coefficients. Well, we have a positive 4 and a negative 2. What's 4 and negative 2? 2. The base remains the same. Do not change the exponent. So I have 4 x's here, I'm subtracting 2 x's. How many x's do I have left? I have 2 x's. Do you all get that? What? What? Just, they're gone because can't use your calculator. I'm missing a calculator, so nobody gets to use it. Yep. All right. Example 2. 9x plus x. First of all, are they alike? And how do you know? Raise your hand. How are they alike?
What are they?
Yeah, Faith.
They have the same variable.
And
They have the same exponent.
same exponent. They gotta have both. If they only have one, then they're not alike. You can't put them together. Right.
Doesn't every variable have one?
Yep. So, Brady, how do I combine them? What do I get?
You get 10.
That's right. This is a 9x, and this is a plus 1x. So 9 and 1, we add the coefficients. 9 and 1 is 10x. Yes? Yeah.
So, if the
Do not change the exponent.
variable, or the little x thing, if it doesn't have a number in front of it, it's just 1.
Yep, it's always a 1.
So even if it does have a number in front of it, like if it has a number in front of it, the 1 doesn't matter.
Well, instead of 1, that's a 9 here. This is 9 times x, that's 1 times x.
Okay.
Just like the exponent's understood, if it's not there, it's a 1. If the coefficient's not there, it's a 1. Everything has a 1. Okay? Alright, example 3. Let's do 2x squared plus x plus 4x squared. Matt, you alright? Got a scratch on it? Yeah, we're gonna talk about this morning. Alright, in the gym, right? Okay. Hey,
6x squared plus x.
why is it 6x squared plus x?
Because the x that's by itself doesn't have the same exponent as the other two.
That's right, so you can't put it together. So here's how you gotta visualize this. Those of you who struggle with this. This one and the plus 4x squared, they have the same variable, same base, so you gotta put those together. This one's different. So all I do is I move my boxes and circles around. If you attach the operation to what follows it, you can move them in any position you want. Okay? Now usually that's a community property of addition, meaning everything has to be addition. You can rearrange everything that's addition. But if you do it like this, I could put this negative 2x here, and that's a positive 4x there. I still get the same answer. As long as I include the sign with what follows it. You all understand that. That's extremely important that you get that. Nephew. I'm sorry? Okay, so this one and this one are the same, right? They're like terms because they have the same letters and the same exponents. So we need to combine them because of that. So I take a plus 2x squared and a plus 4x squared. How do I do that? By adding the coefficients. What's 2 and 4? Gives me 6 of the x squareds. Don't change the exponents. When you add or subtract terms, exponents and bases don't change. And we're going to get into multiplying and dividing when the exponents do change. But when we add or subtract, don't change your exponents. Yeah.
If the letters are the same.
Then you can't put them together. Yes, this is the answer because these cannot be put together. This is 6x squared plus a 1x. You cannot put those together.
So that's your final answer.
That's the final answer. So x squared and x are like this. It's like a marker and an eraser. They're different. You can't put them together. Got it?
So if they're not.
Doesn't matter if the variable's the same.
If they're not alike, you can't.
Right, you can't have it. Alright, so here, let me give it to you like this. I have a 3 squared plus a 3. That's 3 to the first. You don't have to write this down. Alright, the base is the same, but the exponents are different. This is 9, and that's still 3. Yes, I can now add 9 and 3, but they are different values, aren't they? Okay, so that's how you got to think of this. If they are different, x squared and x are different. And until you know what they are, you cannot put them together. I cannot put these two together because they're different values. Until I know what the values are, I cannot put them together. So you don't know what these are, so don't put them together. Do you understand? All right. Example 4. X squared minus 3x plus 4x squared minus x squared plus 5.
I know smart.
Good. You should, because this is difficult to do. We need to make sure everybody in here gets this. You can't do math without knowing this lesson from here on out. Alright? So go ahead and put squares, rectangles, circles, triangles, whatever you want around stuff. But include the operation that's attached to it. Yeah.
With 3x and 5x are the same.
There's not x on the 5. So here's what I do to help you out. I'll just put squares around my x squareds. That's a plus 4x squared. That's a minus x squared. This is an x by itself. It's not x squared, so I'm going to circle it. And then this is a plus 5. That's totally different than all of it. I'm just showing you that they are different. So now I put all the same things together. These rectangles all have the same bases and the same exponents. So I need to combine them by adding or subtracting the coefficients. This is a 1. Plus 4 is minus 1.
4.
So that's a 4x squared. So those are done. Now there's nothing to put together with this x to the first. So that's just a minus 3x. And there's nothing to put with this plus 5. A number by itself is called a constant. So constants are always last. Plus 5. That is finished.
Like, what's the point of doing this?
To simplify. Okay, as we get more complex, you're going to want to be able to simplify problems into something that you can work with. Alright? In Algebra 1, this is a trinomial, where we try to factor it and change the way it looks and graph it in an easier fashion. If we just look at it up here, it's not that simple. So you need to know how to simplify things in order to do other things down the road. Okay, and that's not the only reason we do that, but we want to know how to make things simpler. Isn't this really complex? There's a lot of terms up there. If we can manipulate the way things look by knowing how to do things, not making them up, following rules, then we can make our lives simpler and easier and hopefully be able to make a problem easier. But if you don't know how to do the simplest thing, you got a really complex problem you don't know what to do. You understand? So right now, none of this stuff means anything to you. You don't know why you'd be doing this. But I can't go that far down the road. We need to start with baby steps to get you to where we need to be, okay? If you can't do this and you go to Algebra 1 next year, you're hosed. Okay? You gotta be able to do this. Question? Okay, next one. Example 5. 2x plus 3y minus 4x plus y. Everybody try that. You understand?
Huh?
You understand this?
Kinda.
Okay. We done? I thought I made copies. I thought I made copies for the whole chapter. Hopefully you visualize it like that. You don't have to do what I do up here, but this is to try to help you see what's alike. Yeah.
It's negative 2x plus 4.
Yes. We have these two are alike, so 2 plus a negative 4 is negative 2x. And a plus 3 and a plus 1 is plus 4y. Don't change your exponents. Who got it right? Oh my gosh, you guys are brilliant. Alright, example 6. 2x plus 4y minus 3. X plus 4y minus 3. Addie, what do you think?
It's just the same.
It's the same. You can't put any of them together. Good job. None of them are alike. Good.
Is this like the most examples you've ever done?
I-
Like one lesson?
It depends on how difficult it is. Years of experience has taught me that this lesson needs lots of examples. Example 7. Let's see how quickly you're catching up. What if I only gave you 2 examples? You'd be like, what are we doing? Alright. Here we go. We're going to make it a little more difficult. You guys can't do this, so. You're not smart enough, right?
You're sure.
You are so down put.
Now you can do this.
Oh.
Everybody try, and then I'll work through it. Everybody try.
Those are parentheses.
Yes, those are parentheses. 2 times x plus 3 in parentheses, plus a 2x. So guess what you gotta do first?
Parentheses.
Well, you can't do anything inside the parentheses. So what's it called? What do we gotta do?
Just leave the parentheses.
Well, we
That's
should
what's called.
distribute. Everybody understands distribution, we've done this. Distribute the 2. It's 2 times 1x, which is what?
2x.
2x. Plus 2 times 3, plus on 2x. You don't take that 2 times that 2x, why?
Because it's not like terms.
No, it's not inside the parentheses. It's only 2 times this quantity, that's why the parentheses is there. So don't take 2 times that, it's not inside the parentheses.
Don't take 2 times 3.
Oh, no. So the 2x drops down,
Where did you get the 6?
2 times 3. It's 2 times this whole thing, so everything inside you gotta multiply by what's on the outside. Distribution, we did this back in chapter 1, chapter 2. Okay. So I wanna make sure, I put this up here specifically because students will take the 2 times this over here. You can't do that. Because there's a plus sign there. You're adding this to whatever this multiplication is.
Would you do the 2x plus the 2x then?
Yep, so now you have 2x plus 2x, 4x plus 6. 6 doesn't have an x with it.
Oh.
This is why these examples are.
Before you did the distribution thingy, I was taking the 2x and the x
you can't do
adding
that.
together and leaving the 2 and the 3.
You can't do that until your parentheses are taken care of.
I thought that would be.
So there's nothing you can do in the parentheses. So you're done with parentheses, but what's next? Multiplication. You gotta do the multiplication before you do this addition. So you have to distribute the 2 first. Alright. Example 8. 2x minus x equals 3. Now we have an equal sign. This means, everybody stop.
Wait,
Stop.
okay.
You must simplify the left side of the equal sign, and then simplify the right side, and then solve. We can't do anything on the right side here, so we're done with the right side. Can we simplify the left side? Everybody do that, and then solve it. That's how you do this. You must simplify each side of the equal sign by combining like terms, distribution, whatever, and then solving it.
Isn't it just 1x?
Yeah, so here we have
X equals 3.
a 2x and a minus 1x. Those are like terms. So 2 minus 1, that's how we combine like terms, adding or subtracting coefficients. So you have 2 minus 1, which is 1x equals 3. Oh, we're done. We don't have to do anything else. X equals 3. You can check it. What's 2 times 3?
6.
And 6 minus 3 is?
3.
Oh, it works.
Wait, what happened?
How did you get the 3 on that x though? The second one?
X equals 3. So I'm just substituting 3 back in for all the x's.
Oh my.
All right. Example 9. 3 times the quantity, x plus 6, quantity closed, plus 8x. Parentheses are called quantities. They hold a quantity of things. All right, so everybody try your hand at this. There's no equal sign, we're not solving here, but we are simplifying. So evaluate means to solve, simplify means just combine, do whatever you can. Everybody's working wonderfully. Gosh, this will make your homework breeze. You guys are speedy. Devin's gonna try his hand at this. What do I do first, Devin? Walk me through it.
You gotta take the 3 times x, which is 3x, plus, and then you 3 times 6, which is 18,
Good.
and then you drop down the plus 8. And then you put a box around that, and then put a box around that.
Okay, and you don't have to do this, guys, in your homework. If you need to help you walk through it, then that's fine. Okay, go ahead, Devin.
And then you add those two together, which is 11x plus 18.
That's right. The 18 doesn't go in because it doesn't have an x. Right?
You can put it the other way, right?
Yeah, you can put 18 plus 11x, but here's the thing. This, how I've been writing it up here is alphabetically and highest exponent first. That's standard form. So you should get used to putting your variable terms first. Constants are always last. Okay? It's just proper. Yes, you could write 18 plus 11x, but that's not the proper way of writing it.
I got a nurse, I think my contact's going to fall out.
I got a solution here, or you can go to nurse, wherever you want.
I mean, I don't know where I'm going to put the contact.
Oh, you just need to take it out?
Yeah, I think
Go to the nurse, see if she's got something. Okay, example 10. Here's an evaluated problem. Everybody do it? You guys are getting quick now. X plus 7x equals 64. Combine, simplify, solve. Now solve it. Well, let's go back to chapter 2. I'm going to do this one. So this is 1x and 7x. 1 plus 7 is 8x. Everybody got this from what I can tell. Now we solve it from back to chapter 2. You want to get x by itself. Once you've simplified, now get x by itself. Those steps in chapter 2, identify the term that has the variable in it you're solving for. Get rid of any other terms. Divide off the coefficient.
That's it. Oh.
You're solving at this point.
Oh,
Yeah, I got it right.
Now you can check it. If x is 8, so we have 8 plus, what's 7 times 8? 56. What's 8 plus 56?
64.
64.
Good job.
Alright, example 11. Everybody gets this right? We'll go on. 12x minus 6x equals 90. Everybody do.
Are we solving?
If there's an equal sign, that means you're solving. But you must simplify first. You simplify the left side, and then you simplify the right side. Then you solve. Oh, if you only had a calculator.
yeah.
Anybody caught using their calculator? It's a 0.
What? Wait a minute, we can't use the calculator.
Not until my calculator gets turned into me.
No, I'm not. Okay. Yeah, that's not.
Alright, here we go. These are like terms, right? So what's 12 minus 6? 6x equals 90. How do I solve somebody?
You divide 90 and x by 6.
That's right. Divide off the 6, x equals 15. 15. Your assignment. Page 302, 1 to 45 all.
Wait.
Yeah, how long does it really take you to do